In our daily life, there are some relation between our parents, our friends, and so many relations there exist. Okay, like father, son, daughter, father, mother, friends. Okay, so we can find in this chapter the relation between the elements of two sets. Welcome back to our channel AnganaStudyCenter. Today we will discuss about the relational function, chapter number 2, class 11. How was your previous lesson? Without that, you can't understand this lesson. The basic of this lesson is, in our daily life, there are some relation between our parents, our friends, and so many relations there are exist. Okay, like father, son, daughter, father, mother, friends. Okay, so we can find in this chapter the relation between the elements of two sets. Now, okay, firstly, we can understand the Cartesian product of two sets. Let's enter our main class. Let A and B are two non-empty sets. Okay. Then the Cartesian product A cross B. Okay, that means Cartesian product means A cross B. Okay, is the set of all ordered pair. Ordered pair means the pair which are in order. In order. Okay, ordered pairs of elements. A and B. Okay, that is in roster form A cross B equal to, suppose that AB are the element of A cross B, such that A belong to A and B belong to B. Okay, AB are two non-empty set. Okay, and then the Cartesian product of A and B is denoted by A cross B, is the set of all the ordered pair. Remember that ordered pair mean this is ordered pair. Okay, of elements of A and B, that is A cross B equal to AB, such that A belong to A and B belong to B. Okay, let's see an example. By this example, this concept will be clear. Okay, let A equal to A1, A2. Okay, and B equal to B1, B2, B3 and B4. Okay, then we will find the Cartesian product of A and B. Then A cross B is the Cartesian product of these two sets. Okay, equal to, how we can write? We write as ordered pair as this, the first element with the first element, then within bracket we can write this as A1 comma B1. Okay, then with the first element we write the second element, so A1 B2. Okay, then with the first element we write B3, third element. Okay, then A1 B3. Then with the first element write fourth element, that is A1 B4. Okay, then the work of first element of the first set is completed. Then there is second element. Similarly, firstly, we write this two elements within brackets, then A2 B1. Okay. Then A2 B3. Okay. Then A2 A2 B2. Then here B2. Then B3. A2 B3. Okay. Then A2 B4. Then second bracket close. Okay. So by this we can see that there are how much elements? How much ordered pair? 1, 2, 3, 4, 5, 6, 7, 8. So we have got 8 numbers of ordered pair. Okay. So from the first set, how many elements? In the first set, 2. And how many elements in the second set? NB equal to 4. Then the elements of Cartesian product of the two set will be the number of element of first set into the number of element in second set. So 2 cross 4 equal to 8. Okay. This is also a theorem. Okay. This should be remembered. Some points are to be noted. If a Cartesian product consists of AB and BA. Okay. And so much element. There are so much elements. So here these two ordered pair is not equal. This will be equal if the correspondence first element is equal to the correspondent second element. Okay. That means if A equal to B and B equal to A, that is if A equal to B and B equal to A, if this exists, then this ordered pair will be equal. That means A comma B equal to B comma A. Okay, clear? Then second point, let A and B are two non-empty set. Okay, let A or B is a infinite set. Then element of the Cartesian product of the two set will be infinite. Okay, now we are going to do some example. Look at this question. If x plus 1 comma y minus 2 equal to 3 comma 1, then find the value of x and y. We previously do if a comma b equal to b comma a, then the corresponding first element is equal to the corresponding second element. So in this way we can write this as x plus 1 equal to 3 and y minus 2 equal to 1. Therefore from this x equal to 2 and from this y equal to 3. Okay, we get the values. Here in this question p equal to abc, q equal to r. Then find p Cartesian product of p and q and p. Now let's do this. So here p cross q. What we learn? The first element with the first element of second set. Then we can write this as A, R. Okay. There is no element. So first element work is completed. Then second element with the element of the first element of second set. So this will be B, R. Then third element with R. Here. Okay. This is P cross Q. Now Q cross R. So here this is the only element. Then this will be right as with the first element of the first set. So this will be R comma A. Okay. Then R comma B. Then R comma C. Okay. So now look here. Here no condition has been given such that A equal to R or R equal to A. So these Cartesian products are totally different. So here we can get P Cartesian product Q not equal to Cartesian product of Q and P. Okay. Now look at this question. A equal to 1, 2, 3, B equal to 3, 4, C equal to 4, 5, 6. Find the Cartesian product of A and B intersection C. Cartesian product of intersection of Cartesian product of AB and AC. Cartesian product of A and B union C. Cartesian product of union of Cartesian product AB and Cartesian product of A and C. Now let's solve this question. Here we will do first this. Okay. Question 1. A cross B intersection C. We now find B intersection C first. So B intersection C. Intersection means the common element. Okay. Here 4, 4. 4 is the common element. So B intersection C equal to 4. Okay. Now the Cartesian product of A equal to 1, 2 and 3. Then the Cartesian product of this will be 1 with the first element with the this element 4. Then there is no element. So first element work is done. Then 2, 4. Then 3, 4. Okay. Complete. Second. Cartesian product of AB intersection Cartesian product of AC. Now we have to find Cartesian product of AB. Now AB this. So first element with the first element of B. Then 1, 3. Okay. Then 1 and 4. Okay. Then 2, 3. Then 2 and 4. Then 3, 3. Then 3 and 4. Okay. This is the Cartesian product of A cross B. Then this intersect Cartesian product of A cross C. Okay. A cross C. What will we get? Then the first element with the first element of C. Then 1, 4. Okay. Then 1, 5 and 1, 6. Okay. Then second element with the first element 2, 4, 2, 5, 2, 6. Okay. Then third element with the first element 3, 4, 3, 5, 3, 6. Okay. Now intersection means the common element. Okay. So common ordered pair. Here which is the common? 1, 4. 1, 4, 1, 4. So one element will be ordered pair will be 1, 4. Okay. Then 2, 3 is here. 2, 3, 2, 3. 2, 3 is not. 2, 4. 2, 4 is here. So here also 2, 4. Then 2, 4. Then 3, 3. 3, 3 is not present here. 3, 4. 3, 4 also present here. So this also be 3, 4. Okay. In this way, remaining 2 is your homework. These two will be solved in this way. So this is your homework. Okay. Look at this question. P equal to 1, 2. Then find P cross P cross P. Till now we have done the Cartesian product of 2 sets. Here we are going to do the Cartesian product of 3 sets. Not more different. Firstly, we will find the Cartesian product of these first 2 sets. Okay. Then with that we can find the remaining sets. Okay. Just look at this board. We are going to do P cross P. So we have 1, 2 and 1, 2. So the first element with the first element. So 1, 1, then 1 comma 2, then second element with the first element 2 1 and 2 2. Okay. Now we get P cross P. Okay. Now we are going to find P cross P cross P. That means with this cross 1.2. So in this set these are the element, and in this set this is the element and this is the element. So here we can write, this is the first element. So from the first set we write first element with the first element of the second. Here 1 1 and this is 1 comma 1 comma 1. Okay. Then 1 1 with 2 1 comma 1 comma 2. Then the first element work is done. So there is second element 1 comma 2 comma 1 with first element 1 comma 2 comma 2. Okay. Then with the third element 2 comma 1 comma 1, 2 comma 1 comma 2. Okay. Third element work is done. Then 2 comma 2 comma 1 and 2 comma 2 comma 2. That's the Cartesian product of the three sets. Okay. Here another example. If R is a set of all real numbers, then find R cross R and R cross R cross R. And what will this represent by this? Okay. So R equal to set of all real numbers. Okay. Then R cross R will be represented as x comma y such that x y belong to R. This is represent the coordinates of a point in two-dimensional space. In coordinate geometry we have already found represent the coordinates of a point in 2D. Okay. Then R cross R cross R equal to x comma y comma z such that x y z belong to R. Okay. And this will be represent the coordinate of a point in 3D, three-dimensional space. Okay. Represent of a point in 3D. Okay, clear? Now look at this example. Till now we have done the Cartesian product of two sets where the two sets were given. Okay, but here the Cartesian product has been given. We are going to find the sets. So how we will do? Here look, we have said that in Cartesian product the first element of the first set will be related with first element of second set in ordered pair. So here this will be the first element of the first set. So first set is A and second set is B. Okay. Then we can write P is the element of A. Okay. Then Q is the first element of the second set. So this is so. Then with the first element of first set, there is a relation between the second element of the second set. So here is the first element and this is the second element of second set. Okay. Then QR, and then the first element is complete work done here. Then the second element, this is the second element of first set. Second element work has been started. Then this is M with Q, the first element, set B. Okay, this is completed. Then the second element M with R. That means the second element of B. Okay, these are the sets. Now we will do the exercise number 2.1 from your NCERT textbook. Exercise 2.1. Okay. Now look at this first question. Here x by 3 plus 1 comma y minus 2 by 3 equal to 5 by 3 comma 1 by 3. So from the previously we have seen this type of question. Okay, so this is your homework. Here question number 2. If a set has 3 elements, set A has 3 elements and B has also 3 elements, then find the elements of Cartesian product of A and B. Okay, so we have seen there is a theorem. The elements of A cross B is equal to elements of A and product of the element of A and element of B. So here the element of A is 3 and B also 3. Then the element of A cross B will be 9. Okay, look at this question. G equal to 7, 8 and H equal to 5, 4, 2. Find G cross H and H cross G. So how to solve this? Firstly, we have to find G cross H. 7, 5, 7, 4, 7, 2. Okay. Then the work of second element has been started. 8, 5, 8, 4 and 8, 2. Okay. And then H cross G will be, this is the first element with the first element, that means 5, 7, then 5, 8. Okay. Now second element with the first element, 4, 7, 4, 8. Okay. Now 2, 7, 2, 8. Okay. Answer has been completed. Now here is the question is write true or false. Okay. In the first question, if P equal to M comma N, Q equal to N comma M, then the Cartesian product of P and Q is Mn Nm. Is this right? No, this is false. Why? The Cartesian product will be the first element with the first element, that is Mn comma Mm. Okay, then Nn comma Nm. Okay, this is the right Cartesian product. Okay, then if AB are non-empty sets, then the Cartesian product of A cross B also non-empty set of ordered pair xy, such that x belong to A and x belong to B. This is absolutely right. So this is true statement. From the definition of Cartesian product, we have known that if AB are non-empty set, then the Cartesian product of AB is also a non-empty set contain the ordered pair xy, such that x belong to A, y belong to B. So this is true. Now A equal to 1, 2, B equal to 3, 4. Then A cross A Cartesian product B intersection phi equal to phi. Now so this equation, A cross B intersection phi. Firstly, we will find B intersection phi. The B intersection phi. B intersection phi. What will we get? Phi. As there is no common element, so we have to find the Cartesian product of A and phi. If as phi has no element, phi is null set. So A has this element, but phi is no element. So there is no ordered pair. Okay. There is no ordered pair. So this will be also phi. Okay. So this is true. Now look at this question. A equal to minus 1, 1. Then find A cross A cross A. In exercise, we have done this type of exercise. So this is your homework. If any difficulties arise, then we will solve. Then comment in our comment box. We will solve that. Okay. Let's look at this question. A cross B equal to this, and find A cross B. In exercise, we have done this type of question. Now I am doing this question. Here, the first element of A is A. Now write A and B. So this is the first element of A. Then this is the first element of B. X. Then the first element A will related to the second element of B. So Y is the second element of B. Then this is the second element of A with the related with the first element of B, and this is the second element of B related to second element of B. So these are the sets. Okay. Now look at this question. There are 4 sets A, B, C, D. Then verify that A and B intersection C, Cartesian product of A and B intersection C equal to Cartesian product of AB intersection Cartesian product of A and C. And A cross C is a subset of B cross D. So now, first question, LHS. What is LHS? A cross B intersection C. So now we have to find first B intersection C. B intersection C means the common element of B intersection B and C. So there is no common element. So this is phi. Okay. So previously we have done the Cartesian product of phi and any set will be phi. Okay. Then RHS. A cross B intersection A cross C. Okay. Then A cross B equal to A and B. So 1 1, 1 2, 1 3, 1 4. Okay. Then 2 1, 2 2, 2 3, and 2 4. Okay. Then intersection A cross C mean this and this. 1 5, 1 6, and 2 5 2 6. So look at this. There is no common between this Cartesian product. So this is also phi. So LHS equal to RHS. So this is verified. Okay. Now question number 2. A cross C subset of B cross D. So we get A cross C equal to 1 5, 1 6, 2 5, and 2 6. Okay. And B cross D. What will we get? B and D. So 1 5, 1 6, 1 7, 1 8. Okay. Then 2 5 2 6, 2 7, 2 8. Okay. Then 3 5, 3 6, 3 7, 3 8. Okay. Then 4 5, 4 6, 4 7, and 4 8. Okay. Now look at this. Two Cartesian product. 1 5 also available in B cross D. 1 6 also available in B cross D. 2 5, 2 5 2 5 also available. 2 6 also available. So all the member of A cross D is available in B cross D. So here A cross D is subset of B cross D. So this is also verified. Okay. Now here question number 8 is the topic of your next session. Okay. So this will be done in next session. Okay. Now look at this question. Here A, B are two sets. Okay. N mean the elements number in A is 3. Okay. Then the elements number in B is 2. Okay. So then x1, y2, z1 are in A cross B. Okay. Find A cross B and where x, y, z are distinct elements. So by the Cartesian product, the definition of Cartesian product, we have seen there is relation between the ordered pair. First element is the first element of A set, and the second element is first element of set B. So here look, x comma 1. So x is the element of A. Okay. Y2. This also y also be the element of A, and Z also the element of A, because they are in the first position. So from this, by the definition of Cartesian product, we get what? We get A equal to x comma y comma z. Okay. Then we have to find B. B equal to, here look, B has only two elements. So here 1 and 2 are the element of B. So 1 and 2. Okay. This is your answer. Now look at the question number 10. The Cartesian product A cross A has 9 elements, among which are found minus 1 comma 0 and 0 comma 1. Among the 9 elements, these two elements are exist. Then find set A and find A cross A. So how? Just imagine A is a set, non-empty set. Let x element are here. Okay. Then A cross A, the number of element mean n bracket will be the number of elements of A cross number of element of A. Okay. So x cross x mean x square. So this is 9. X equal to 3. Okay. So we get A has 3 elements. Now A equal to this is the element of A, 1, first element. Let A be the first phase, first set. Okay. Then minus 1 is the element, and 0 the next element. Okay. Then it is the product of A and A, Cartesian product of A and A. So 1 will be also the element of A. So there is 3 elements. Now we are going to find A cross A. Mean there is also A equal to minus 1 comma 0 comma 1. So now the first element with the first element, minus 1 comma minus 1. Okay. Then minus 1 comma 0. Then minus 1 comma 1. Okay. First element work has been done. 0 comma minus 1. 0 comma 0. 0 comma 1. Then third, 1 comma minus 1. 1 comma 0. 1 comma 1. Okay. These are all the elements of A cross A. So from this, here is this and 0 1 this. Okay. A relation R is a non-empty set A to B is a subset of the Cartesian product of A and B. The subset is derived by describing a relation between the first element with the second element of the ordered pair of A cross B. A relation is a non-empty set, also a non-empty set. Okay, and it is the subset. It is also the subset of Cartesian product of A cross B. That means R contains the elements that are also belong to A cross B. Okay, then the subset, that means R. R is derived by describing a relation. So R is a relation. R describes, R express the relation between the first element and the second element of the ordered pair. That means we have write within bracket A comma B. Then there is a relation of A with B. Okay. That means there is relation between AB is a, let AB is a ordered pair. So there is a relation between A and B. Okay. With the ordered pair of A cross B. A element of A cross B. Okay. This element B is called the image of A. Okay. And A is called pre-image of B. Okay. So this is clear. Let P equal to A, B, C. Okay. Q equal to Amit, Bhaktu, Kitu, and Ajit. Okay. Then Cartesian product of P and Q will be A comma Amit, A comma Bhaktu, A comma C2, A comma Ajit. B comma Amit, B comma Bhaktu, B comma C2, and B comma Ajit. C comma Amit, C comma Bhaktu, C comma C2, C comma Ajit. Okay. These are the elements of P and Q. So we get 12 number of elements in P cross Q. Okay. From P and Q, P cross Q, let we obtain a relation R is a subset of P cross Q. Okay. We have seen from the definition is expressed as R equal to X comma Y. Say that X is the first letter of name Y. X belong to P and Y belong to Q. Now look at this element. X is the first letter of name Y. So in Q set there are 4 names and in P set there are 3 letters. So here name of it, the first letter is A. So here A exists. So R equal to A comma Amit. Oh, okay, this satisfies this relation. Comma. Then A Ajit. This also exists. Okay. Then B Bhaktu. Okay. C C2. Okay. So this relation contain 4 elements. There is a relation describing here. Okay, with the first element, with the second element. So this is a relation. So we get this relation. Now let these are two sets. This is P and this is Q. Here elements are A, B and C. Here Amit, Baptu, C2 and Ajit exist. Now there is a relation A and Amit. This can be expressed as by the arrow mark, and B2 Baptu, C2 C2 and A2 Ajit. Okay. This is called the arrow diagram. So relation can be expressed as this form, that is roster form, this is tabular form, and this is arrow diagram. Okay. Domain. Here the domain of R, if there is a question, a relation exists this type. Okay, then says what is the domain of R? Here in ordered pair, the first element, set of all the first element in relation R from A to Q is called the domain of the relation. Here I take P and Q as sets. There will be A, B, C, D, any of these. So domain is the set of all first element in a relation from two sets. Here P and Q. So look at here, the first elements are A, B and C. Here A repeat two times, but we write this as one time. Okay. So this is the domain. Okay. Then range of R. What will be the range of R? So this A, B and C is the domain. Okay, this is the domain. And all the second element in a relation from P to Q. P to Q is called range. So here range will be Amit, Baptu, C2 and Ajit. Okay. So range will be Amit, Baptu, C2 and Ajit. Okay. Now we will do an example to better understand this. Now look at this question. Let A equal to 1, 2, 3, 4, 5, 6. Define a relation from A to A by this condition. R equal to xy such that y equal to x plus 1. So here y is the second element and x is the first element. Here look, x is first element, y is the second element. So there is a relation between A to A. That means two sets are A. So now solve this equation. Y equal to x plus 1. Here A equal to 1, 2, 3, 4, 5 and 6. Now to get y, we have to put x equal to 1. So now put x equal to 1, we get 2. Now we put x equal to 2. 2 plus 1, we get 3. Now y equal to, we put x equal to 3. 3 plus 1, we get 4. Y equal to 4 plus 1 equal to get 5. Then y equal to 5 plus 1 get 6. Y equal to 6 plus 1 get 7. Okay. Now we get this all. So the relation will be x comma y, mean x1 we get 2. Then x2 we get 3. Okay, then x3 we get 4, x4 we get 5, x5 we get 6, x6 we get 7. Okay, this is right. No, as there is no 7 in between the elements of A, so this is not true. Okay, so this element can't exist. So only 3, 4, 5 up to 5 and 6 elements will be exist in R. So now by diagram we can express this as there are two sets A and A. Elements are 1, 2, 3, 4, 5 and 6. Here also 1, 2, 3, 4, 5 and 6. So there is a relation 1 and 2. So 1 to 2 by arrow diagram, 2 to 3, 2 to 3, 3 to 4, 3 to 4, 4 to 5, 5 to 6. Okay, this is the arrow diagram of the above relation. Okay, then write down the domain, range and codomain. Okay, here look, we have known that the first element of the ordered pair, the set of all the first element in the ordered pair of the relation R from A to A is called the domain. So the domain will be here all the first element up to 5, 1, 2, 3, 4 and 5. So this is the domain. Then range means the set of all the second element related to the first element. So here from 2 we have found up to 6, from 2 to 6 there is a relation. So the range is 2, 3, 4, 5 and 6. Okay, now there is a another term which is codomain. Codomain. Which is the codomain? All the elements of the set A. Okay, then we here A to A mean I call this set is A, but there will there may be B, C, etc. Okay, so in this set all the elements, set of all these elements in this set is called the codomain. So codomain will be 1, 2, 3, 4, 5 and 6. Okay, so there is a clear concept about this. So that's all for today's class. Next class we will exercise some problems, and there will be some miscellaneous exercise, and we will start the function. What is function? There is some properties of function and the diagrams of function. So let's practice all the problems we have done today. Thanks for watching our video.